Ladies and gentlemen, hello, greetings and salutations. This video will cover the changes, the updates, and the cool applications recently installed in Skywave Linux version 4.4. Version 4.4 is available for download now. Visit skywavelinux.com for the download links. It's coming out in two flavors. The one you'll see today is the i3 Window Manager version. Soon there will be another upload of Skywave Linux containing the GNOME desktop environment. Again, that one's not ready, but it will be out shortly. So, let's talk about the changes that I've made to the i3 Window Manager, all for your convenience when you're using Skywave Linux. i3 is a tiling window manager, which means it will automatically size and place the windows of the applications you're using. They will operate in tiled mode where they're sharing space on the screen. There's also a floating mode where your applications will open centered on the screen and on top of other application windows. I have set up an automatic show and hide feature which uses the Scratchpad workplace. Specifically, your terminal and your file manager will both open initially as floating windows now. They'll open as floating windows on top of whatever else is on the screen. So use a keybind to start them. They'll pop up as floating windows. To make them go away when you're finished, don't close them or shut them down. Simply repeat the key binding and they'll be moved to the Scratchpad. Out of sight, but hopefully not out of mind. Now watch this. I'll use Super Enter to bring up the terminal. Remember, the terminal comes up with Super Enter and also with Control Alt T. Either of those key bindings work to open that. Now, if I repeat the key binding, Super Enter, the terminal disappears. It's been moved to the Scratchpad. It is the same terminal. I'll throw some text on the screen. How about that? Now you see it. Now you don't. Now you see it. Now you don't. The idea behind this is to keep it convenient. The first time you open it, there might be a slight delay depending on the speed of your system. But then, on just about any system, to get rid of it, it's gone in a flash, and to have it again, repeat the keybind, and it's back in the blink of an eye, or even faster than that. Let's check the quality of the timekeeping of the system. Hey, it's keeping good time. Very good. Let's use the calculator. It's a Python calculator. Quick, someone tell me what's 2 plus 2? The computer says it's 4, and I believe everything the computer says. So, there it is. Control D to get out of that. Simply just clear the screen, repeat the keybind, and the terminal is gone for the time being. Super F brings up the file manager. Repeat the key binding and it's gone. Hit Super F again, and there it is. Now, instead of opening multiple independent windows when you're moving a lot of files around, remember, you can open tabs in the file manager. Control T, Control T, Control T. Keeps them all in one place, nice and neat and clean. One other suggestion for uncluttered computing, in addition to using tabs in your file manager, is put some of your other applications on a different workspace. For example, I've got the terminal on workspace 2, the file manager in workspace 1. Now, the terminal can also operate in a tabbed or multi-window fashion. If you open this terminal with your key bindings, Control-Alt-T or Super-Enter, tmux will be available, and tmux can very easily give you new windows. Use Control-A-C, Control-A-C, Control-A-C. Now look at that, I've got multiple windows here. Control-2, correction, Control-A2, Control-A1, Control-A0, and these are all different ones. 1, 2, 3, 4, 5 on the first one. On the second one, 6, 7, 8, 9. All right, Control-A3. Let's see. Trump is a something, A in lowercase, something else. Yeah, how about that? You knew I had to throw something like that in there. Every single video I put out has some kind of a quip. But move away to another window, Control-A2, Control-A1. All right, Control-A0. And whenever you're finished, just quit out of it. Control-Q works. I put some Vim keys in there as aliases. I'll even clean out that vile and profane statement about the former president. All right, so there we go. I'm even going to get rid of this one. I don't think we'll need the terminal for a while. Neither will we need the file manager. Let's just hit the key bind. I'll save it just in case I need it. Now, let's move on to some applications in Skywave Linux that have been added. You're currently looking at the application launcher, Rofi. It's available by using Super R. If you don't like to use the keyboard so much, that menu is available by simply coming up and right-clicking on the workspace number. All right. Or click on this blank space to the left of the status line. Click in that empty space, and there it is. Click on the empty space. And I had somebody giving me a hard time earlier. It says, oh, they don't like i3 because it doesn't have a start menu. Come on. You didn't think I was just going to put something out with no start menu? All right, it's not really called a start menu. It's an application launcher, but there it is. And it's a fuzzy finder. I would like to talk a bit about something called the SDR Map. It's in the menu. You can see it. It's number 2 in the applications and number 4 in all of the items, because we have some other things that are on the scratch pad, and Rofi tells us that they're there. All right. Now, Rofi is a fuzzy finder, which means I can start typing in some letters and it will start to rearrange the list. See that? There's a capital S. Now that's case sensitive. SU. And the list has pulled SuperSDR and surfraw because I entered a capital S and a lowercase u. How about that? If I go lowercase, well, still, those are the two that the fuzzy finder catches. Capital C, U, oh, well, there's cubic SDR. All right, do you get an idea of how the fuzzy finder works when you're looking for applications? Because it can be a rather long thing here, this list. There are a lot of applications in Skywave Linux, and there are other flavors of Linux that people are using with Rofi that have just incredibly long lists of applications. SDR Map is something that many of you have seen if you are a user of the Kiwi SDR servers around the world. This is exactly the same map that you'll find on linkfunnel.net and on SkywaveLinux.com. Both of those maps use the Dyatlov map maker, and the map is populated with geographic locations of Kiwi SDR receivers. And in fact, in the static list, I have added these green markers, which are all web SDRs. These web SDRs have been chosen mostly for medium wave and general shortwave coverage, but there are a few that are ham bands only that just have outstanding features or performance. In particular, I was pretty psyched to put on this one for the Northern Utah SDR group. They have at least one Kiwi SDR and a whole group of web SDRs, and they perform absolutely great. So those are in there on the list. They're all located in one place, but obviously you can't put these flags all in one location on top of another. It gets really messy and you have to zoom in really close in order to see them. So I've played around with the coordinates so that they'll spread out a little bit. You don't have to zoom in quite so much. But there are a bunch of web SDRs in North America, some in South America. They're great for medium wave listening and long wave. There are some over in Europe, too, that are really nice. Are these two here. This one is in Belgium, and it's got a great 40-meter receiver, and medium wave is good, too. And, of course, the stupendous web SDR at the University of Twente in the Netherlands. This map updates automatically. Okay? Whenever you click on it, it's going to check the age of the database file, and if the file is beyond a certain age limit, it will download fresh data, and that data is used to plot positions and to change the color of these indicators based on the signal-to-noise ratio score, the SNR score of the SDRs. The SNR score is not available and it wouldn't change for these web SDRs. They're not as sophisticated. The Kiwi SDRs are certainly more sophisticated, and there's a lot more monitoring of their performance. Notice that the colors are a lot more bright over here in Europe. Europe is in darkness at the moment, and the lower bands are open. And with low band propagation, the SNR scores tend to increase. Those signals are quite strong, especially on the 49-meter broadcast band, and also medium wave and other frequencies too. Over here in North America at this time, it's daytime. The signals on the lower frequencies are being absorbed. They're weak and they're noisy, and the SNR scores are lower because of that. The propagation on the higher bands is really not that strong, and it doesn't help increase the SNR score. Now, there is one thing which will greatly juice and magnify the SNR scores, and that's if the operator is using an amplifier on the antenna. If there's a preamp, then the SNR scores go way up. Over in Kuwait, they're scoring 27 dB, which is pretty good. There's 42 dB on this SDR in Spain, 35 dB from one over in Lisbon, Lisboa. Now, with those preamplifiers, they will amplify a lot of noise, and they'll also reduce the dynamic range of the receiver. So I am not a proponent of high-gain amplifiers for shortwave receivers. You just need enough gain to get above the natural background noise. any more than that is simply harming the performance of the radio. So a lot of these operators are artificially magnifying their SNR scores, and it doesn't really help so much. If I can find a Kiwi SDR with a 20 dB SNR, I'm happy. I'm even happier if it's 22, 23 dB. If they're scoring 35 or 40, that's just overkill, and I'm not more eager to operate one of them because of their ridiculously high score. Now, there are some new ones which are pretty neat. There's a new one over here in Thailand. I believe the town is Chaam. The only town besides Bangkok that I can pronounce is Chiang Mai. But this one is great. The reception is really, really nice on this one. Medium wave is good. HF is also good. And we've got some other ones. There are some starting to show up in China. There's one which appears intermittently in the Philippines, and there are two down here in Indonesia. Sometimes they're on, sometimes they're off, and that's the importance of having a map that will check the database and update. There are a whole lot of them over here in Japan, mostly 0 to 30 megahertz. There is one over here that has a converter on it that receives VHF aviation band. It's located not too far from Tokyo, so it's pretty slick. All right, so those are the Kiwi and Web SDRs that you can find using the SDR Map application, and that opens a window here in the browser. Here's where the file is actually located on the system. All right, let's go and look at something else. Now we're getting really into the meat of this briefing that I'm doing here for you. There's an application called DirectKiwi. It is a Kiwi SDR client. It operates independently of your web browsers. It does not use Firefox or Chrome. Okay? It uses Python, and it makes WebSocket connections to the Kiwi SDRs. It also has a utility that will get the database information, and it will update the information and plot points on this map. The brighter green ones are the SDRs with a higher SNR score. The darker green ones have a lower SNR score. You update by hitting this button here. That will cause the utility to go and check the database, download new information, parse it, and produce a list. I believe it's in JSON format. You can adjust the audio bandpass. 100 hertz to 3000 is pretty standard for communications quality audio. If you're listening to a broadcast and you want more highs in the sound, you can widen the filters and bring it all the way out pretty close to 6 kilohertz. Frequencies are entered here. It is important when you are opening up streams from these SDRs that you have a frequency here first. So let's try 7850, the frequency for CHU, and an upper sideband. All right, so there's a frequency, there's a mode, and I know the database is up to date. I used it earlier, and it will group stations that are physically close together under one dot on the map. Let's open up VE3HOA. And there's CHU. Now, I can try to change modes and select the lower sideband. Notice that it doesn't do anything, right? This interface is perhaps a bit crude in that it doesn't change these parameters until you click on it again. Clicking on it again will then restart the stream in the new mode. And I don't believe it changes the bandpass either until clicking again. Let's see what happens. Let's try one more time. Now, CHU transmits upper sideband. Mostly there's a bit of vestigial lower sideband. Let's switch modes. I want to demonstrate that the bandpass also requires a restart of the stream. Alright, so here we go. Alright, now the default version of DirectKiwi was missing some operating modes, so I manually went in and added some more code so that we have synchronous AM upper and synchronous AM lower, because I do a lot of broadcast listening, and synchronous AM is a fabulous way to listen, especially when there's interference or QSB. Let's change frequencies. 5,000 kilohertz. All right. And November 6th, Golf November. There's WWV. Received in Colorado. This also operates CW narrow with the appropriate offset and narrower band pass. All right. So there it is. So that's DirectKiwi. It's a nice application. It gets you out of the web browser, and it's got some decent features. Now to quit this one, use Control Q, okay? And then confirm that you want to exit. The real gem, the star of the show when it comes to Kiwi SDR clients, is SuperSDR. This also uses Python. I have worked on the code and set it up so that Rofi will present a list of the top Kiwi SDR receivers ranked by SNR. It will read the database and sort according to SNR and then show the top 50. I'm probably going to change that number to 70 or 100 receivers in a future update, because there's one group of them and it's always the same group. If you want to find some of the more obscure receivers, it doesn't really show them because they're being squeezed out by all of these operators with the big amplifiers on their receivers. Let's look around here. In the French Alps, there's a very nice receiver. So select it. Wait, before I hit enter, I want to demonstrate again that this is a fuzzy finding list. Capital C-R-O-C-R-E, nothing, Croydon. So we'll, did I just kill it? I think okay, I've got something coming up. This is going to be a high sensitivity radio. So there's 10 megahertz. It will choose the operating mode automatically based on the frequency. To quit, use Shift Escape to get out. All right. So SuperSDR, just start typing SU when you get this list here. This other application is a search tool for SuperSDR. I'll hit enter and let's pick something interesting. How about Hagenau? This is a good receiver. I've used this one before. The status is connecting. connecting. And there it is. For help with this interface, hover over the word help on the lower right, and this list comes up. It gives you a whole guide to the key bindings to use. Use F to enter a frequency. Use Shift Escape to quit. And there are a whole bunch of other keys. I want to talk about changing receiver modes. Right now we're in AM and it's automatically chosen. If you hit A, now it's manually selected. Shift A brings up the synchronous AM detector. And U for upper sideband. L for lower sideband. Is that too small? Use the up arrow to zoom in close. Here's upper sideband. L for lower. And let's find something interesting here. Let's go to upper sideband. F for frequency. And 5505 for Shannon Volmet.
6,000 feet.
So there it is. I'm going to zoom out a little bit. You can adjust the receiver bandpass by using the J and K keys. J is for the left filter skirt. Just hit J and it moves out or down. K is for the upper skirt. Hit that and it moves out or up. To go in the opposite direction, hold down the shift button. Hold down the shift to move inward and narrow the bandpass. So instead of the default 3 kilohertz, I've brought it out a little bit, 3.7 kilohertz or so for the receiver bandpass. So there it is. It's good receiver quality, and the waterfall display is very nice indeed. The parameters can be adjusted through the keybinds. I find the default works well, but if you want to modify the lower and upper limits, the colors of the waterfall, that's possible too. Let's go into the amateur bands. Frequency 7020. 7020. There's no timer on that frequency entry window, so you don't have to hurry. Take your time, enter the frequency, look at it, or as we would say on the airplane, I have the other person look at it too. Check, execute. So we're going to move to 7020 because we're going to change modes. C for CW. Notice that the filter bandpass narrows and the offset is automatically set. I'm going to use the left arrow to slide down in frequency, find some signals. So there it is, very nice CW reception. Now hold down the arrow key, there's a strong station right there. Now to put that one in the center, hit the space bar. And it centers the receiver passband. In CW mode, notice that what it has actually done is it put the phantom BFO frequency right there in the center. The offset is apparent, and you can see it. The signal is not centered. The phantom carrier, or the old BFO frequency when we had analog radios with an actual BFO, that's what's in the center. CW is using upper sideband. Okay, what else is out there? Let's find some signals. Frequency 9700. Let's go into the broadcast band and look around. A for AM mode. Remember, A for AM, Shift A for synchronous AM. I have not altered the modes to set up synchronous AM upper or synchronous AM lower. just simply use upper sideband or lower and adjust your filter band pass with the J and K keys if you're going to receive. Now, the difference is that upper or lower sideband will not track the carrier in frequency and phase, so there is a difference, but it's often a negligible difference if both the receiver and transmitter are stable and not moving in frequency. Let's try BBC Radio 4 long wave. That's 198. Yeah, there it is. There it is. It's a bit weaker than on the UK stations. To exit from this SDR, hit Shift Escape and we're out. Bring up Rofi again. SuperSDR. Let's try something which is up close near the BBC transmitter, and let's get a look at Radio 4 long wave up close. Let's inspect their signal. Connecting, and there it is. Again, 10 megahertz by default. F198. There it is. Let's zoom in.
So in education, we need to separate that HI and AI, and so there's been so
And
many
there it
reports over
is.
the past couple of decades, whether it's the World Economic Forum,
The
whether it's
BBC is interesting. When you look at the
it's about
spectrum
all
of their
things
signals, you can see there are
skills,
specific
collaboration,
bands
leadership, kind of all the
of
skills that we
audio.
actually
I
learn
have a
at
hunch that they're
school,
using a
drama,
multi-band
music, all of those
audio
subjects that actually have become less
processor
important
that
in the English
splits
curriculum.
their
And I
audio
think
up
what we
into
do need
multiple
to do is
bands,
a
compresses it,
dramatic shift from our
and
current
gives them
education system, where it's
a more
currently
dense
focused, to one that
modulation.
can augment AI to superpower the human intelligence.
So that's pretty slick. What else is out there right now? Let's check the other aviation frequencies. F559 or 8. Notice we changed frequency and went automatically to upper sideband. There are some data bursts that sometimes appear down below 559 or 8 on the lower channel. There doesn't seem to be much going on there right now. They might be down on 3016. Let's just check since we're up here. All right, there's someone.
Contact Iceland on primary HF of 127.85.
Is it Gander or Shenwick?
HF for Iceland 8864. Your secondary for Gander is 88901. Go ahead.
So these Kiwi SDRs receive very nicely. I tend to not like the sound when it's using compression, data compression, although it makes for a somewhat lighter load on the network stream. But with so many people using good quality broadband, that should be less and less and less of a factor as we go into the future. This one takes the signal and does processing here. It's all very nice. Let's see, what else can I show you? I don't know where to find any narrowband FM. Sometimes there are studio transmitter links which operate somewhat under the 10 meter and 11 meter communication bands, 25, 26 megahertz. But I haven't searched for them recently. And I think SuperSDR is a great tool for monitoring CW sideband and AM without using the web browser. So there it is. Have fun with this. Enjoy it. And when the next iteration of Skywave Linux comes out. We're still waiting on version 4.4 with the GNOME 41 desktop. I'll upload it. The problem with that is there's a performance degradation. Something is happening in there which is causing a lag, a delay, which is really annoying. I'll have the terminal open and I'm trying to do something on the command line, and it will not respond to the key inputs until at least a half second, maybe 1 or 2 seconds later. The CPU load is going up, so something is being bogged down in there. It's eating processing power, and it's causing the computer to run slowly. I've got to find what that is and remedy that before I can release it to the public, or otherwise everyone's going to complain and no one's going to use Skywave Linux. Now this version with the i3 window manager has no such problems. It's lightweight, it's fast, it's a boot disk or live environment which changes your PC into the most fabulous shortwave receiver that ever was or ever will be. So there it is. Thank you for watching. See you again soon in another video.